All right, well, welcome to the At Scale podcast. I'm Joe Spisak. We're here filming live at the AI and Data at Scale event. I'm looking forward to my chat with Ion Stoica. We're going to chat about everything from reinforcement learning to academia and industry, VLM, PyTorch, agentic frameworks, why the hell there's 93 of them, all kinds of crazy stuff. So look forward to the podcast. So really cool chat with Aparna. You guys talked a lot about RL, talked about evals. I guess you have obviously your startup world, you have Berkeley and Skylab. What was kind of your biggest takeaway? What was like your favorite topic you guys chatted about?
I really enjoyed as a fireside chat, and the reason I enjoyed is that it touches on many of the things I'm excited about, including, like you mentioned, the reinforcement learning.
Yeah, I saw your eyes light up there.
Yeah, it's like we've been working on that. We've been working on that like for the past 15 years. Yeah. So it's great and to see that gaining so much steam recently. And then, as you know, I've been very passionate about these large language model evaluations. So it was great to talk on these topics.
That's cool. Yeah, I remember 10 years ago, I remember I got pitched by Gary Marcus and remember Geometric Intelligence. They were pitching a new RL. And I was like, it was beyond DQN, and they were using, I think, Pong as the example, right? It was like a smoother Pong.
Absolutely.
Better than DQN. I was like, RL, are you guys, is RL going to have an actual application? Feels like we're finally there. So this is super cool.
Absolutely there.
Yeah, it's at Scale conferences. I remember we did the keynote last year when I was building llamas, when I was building foundation models, and it's a pretty interesting conference. It's one of the few that actually dives down into the infrastructure kind of layer, which I think is like right up your alley with Skylab. And you and I have been partnering on a lot of open source projects, and they're kind of deeper into the stack than kind of like most developers go.
I started, my PhD was in networking.
Oh wow, I didn't know that.
Of course, I was. I graduated in 2000. Mm-hmm. And if you remember then, that everything was about internet.
That's true. Yeah.
So I was right there in the middle of it.
Yep.
It was really very exciting. Right? You go to conferences, everyone is super excited about things happening. I remember you have some of these guys like AT&T and so forth back then. They were doing very well. They were checking the stock on their phones and so forth, right? Yep. Because it's so that was very exciting. And then I kind of went up the stack. Mm-hmm. After that, I did work on peer-to-peer. Mm-hmm. And for me, the reason for going up the stack was that at that time I concluded, it's very hard to have, at least for me, a big impact in networking. It was, convincing Cisco or someone to add some of algorithms I was doing back then to their routers. And then I went, okay, I'm going to go where it's easier, up the stack. And then it was peer-to-peer, right, if you remember. So I worked a little bit on peer-to-peer. And then, big data and now more AI. That's kind of was my journey.
I mean, I remember graduating and thinking, because I was electrical engineering, and this was like right around the time of like the .com really exploding. I think I finished undergrad in 2000, and I'm like, shit, did I get in the wrong field here? What the hell am I doing here? And I started designing chips, and like a whole world was going like software and the web and web apps and Yahoo like was hot at the time, right? And Google was just getting started a few years later.
Yeah. It's you definitely pivoted.
I had to pivot. Boy, did I have to pivot.
Even in my PhD, I pivot a little bit because when I started my work, I was doing more kind of operating systems. Yeah. Scheduling operating systems and so forth. And then, you're doing resource management, scheduling. Networking is more interesting this time. But I'm happy that I do this kind of also the operating systems, because I developed with some other people then this kind of algorithms, which is called this very long name, early eligible visual deadline first. But the reason I'm saying I'm still happy, because after all this year, actually, it made it in Linux.
That's
now
cool.
It's kind of
that's really cool.
default scheduler like as of last year.
Wow.
I totally forgot about it and things like that. And it's funny how things happen.
Yeah.
Right. You know.
I mean, a lot of my career was in closed areas, probably like in maybe the early days. I mean, getting stuff into Linux it's monumental. That's impact. I mean, everyone uses obviously Linux. I mean, one of the biggest things that excited me when I first met, for example, like Yanqing at Berkeley when he was a PhD student, I was like, the guy's building, something that's foundational to so much. And it blew me away because I had spent time in the compression world dealing with, these MPEG, LA and patent pools and all this, and people trying to make money off essential patents. And so for me, like, it was such a breath of fresh air to get into AI where everything was like pretty open.
Yep.
I mean, was that the same for you or?
Yes. I think that although, opening or the open, so first of all, in some sense, it's actually, the internet was, of course, you have companies like Cisco, Nortel back then, and many, and AT&T, and but it was a very collaborative space, for lack of a better name.
Yep.
And this was because, if you remember, internet, or before ARPANET, was founded by DARPA.
That's right.
And then you have right now, in those years, you have a very still tight collaboration between academia, industry, and government, right? I think NSF was really formed officially in '89 or something like that. And so then the government, the body, the standard body, was IETF, Internet Engineering Task Force, and the IETF was still run by a combination of academics and industry. So it wasn't at that time like all these others standard bodies, which are really run by industry at that time, like IEEE and things like that. So that's kind of how I that was my experience. And then on like the previous organs, the operating system and so forth, it's kind of FreeBSD at that time. It was Linux and so forth. It's still open. And then I think that peer-to-peer was it was kind of not a very long time I spent there, because it was flashing and then go very fast up and then tapered off. But then big data was Hadoop.
Yeah.
Right. And so I think that I was lucky enough to be in this kind of open source, so to speak, or in a kind of this kind of academia industry collaborative environment since my PhD.
I mean, when you say standards bodies, I mean, I just immediately get an allergic reaction. I think, you know what I mean? I think about like long cycle times, getting a bunch of companies who aren't incentivized really to work with each other, right? Because they're all trying to make money and they're all trying to own that standard.
Many of them competing.
Right. They're all competing with each other. They're all trying to make millions or billions of dollars, and they're trying to get these people to come together. Is like, it takes years. That's why IEEE standards take years. I think though that like, this is the fun part about AI in some ways. It's probably like it's like the messiness, but also like the goodness of AI is standards are very much de facto.
It's exactly.
Right. Spark is a de facto standard. PyTorch has become a de facto standard.
Totally.
Yeah. Onyx for a little while was sort of a de facto standard, right?
Totally. IETF, was basically this kind of having, I think, Dave Clark, set kind of this charter and others. And basically they are saying is that it's going to be run, by consensus, not like rough consensus. Yeah. Right. Not everyone has to agree.
That's right.
And the condition to have a standard is to have two different implementations of that kind of standard. Yeah. So it was a little bit different at that stage. I think that clearly, right? It's like, but still, I think it became towards when I was a student, more kind of political because the economic interests, like you said, were much, much higher. So it was different when it was, primarily in the network was for academic research purposes, but then it becomes commercial with the internet. Then obviously it becomes more, there are a lot of more interested things then.
I mean, one of the reasons why I like the AI space is because it is meritocratic in nature. I think if you build the best thing and you capture developers, like you'll win, right?
Absolutely.
And I would think like VLM, for example, has done that. Like VLM, how old is VLM as a project? What, a year, year and a half?
2 years.
2 years now.
2 years.
It doesn't feel like it's been around 2 years.
Yes, it's like this is what I was telling people that to appreciate that when we started, like Spark, it was started in 2009. It was open source in 2010. We started the company, did Databricks in 2013. So it was like 4 or 5 years. And when we started because Spark back then, it becomes really, popular. The same thing with Ray. It was again 16 started, and then company started in 2019 on Anyscale. So it's again 4 years. But now VLLM, and again, I'm saying that because when the company started, the systems are reasonably popular, right? It's like, by no means dominating, right? Because, but popular. While VLLM is started, it's like 2 years ago, right? And it's for a while now, it is super popular and so forth and much faster. So it's like the time compresses. Maybe it's also true that it's slightly easier with a library than the distributed system.
Totally.
But still, it's kind of an amazing run. In some sense, some of the project I'm most excited. One of the projects is like both VLLM and LM Arena, previously Chatbot Arena. I started. I was looking at 3 years ago. I mean, Chatbot Arena was in April, May 2023. It's when you guys release, I think, after you guys release the first Llama. Llama. That's what it is. That's how that's actually, I think that's an interesting thing because this is kind of what started everything. So you guys released Llama. And people started to fine tune it. And we were one of the fine tuning Vicuna. Right?
That's right.
And that was using this shared GPT data, high quality data. We curated them a little bit. And the Vicuna performed really, really well.
That's the beauty of open models, right? Open weights.
Yeah, that's a part of the open models. And then it was so fantastic, like because if you think about it, because Alpha existed, then Vicuna existed. On Vicuna, the problem was about because it was chatbot. How do we evaluate it? Right? And the first thing I'm saying, like, what you are, faculty and so forth. What do you do? Right? You have graduates. Get some undergraduate students. Give some pizza and so forth. And just
it's amazing what pizza
evaluate, right? Evaluate it. So we did that and kind of things. Like it wasn't very fast. Right. It was
I was shocked. Right. How fast these things were happening.
So it was very fast to evaluate. So then we think about what we are going to do. Now the other thing what happened is like 2 weeks before we had this problem. GPT-4 was released. I was thinking, why don't we use this instead of humans? So the first results are pretty good. So this is our paper, which was about the LLM as a judge. Right? Published there. But then people are still asking, because early on, maybe LLM as a judge is more accepted, obviously, now than back then. But people say, these are anecdotal examples, but how really it's working? It's like humans, right? So then we did Chatbot Arena. Right? That's a way to scalable evaluation. And then we have to serve some of these models. Right?
That's right.
So it started with TGI.
Right? I remember TGI. From Hugging Face.
It's from Hugging Face. And then we had these students, Usuk and Johan.
Yep.
So what? Oh, like it's too slow. We don't have resources, right? It's like we kind of patch some servers. It wasn't enough, right?
Yeah.
Because it's so slow. You have a few queries per second, A100, right?
A100s, yeah.
And that's kind of started to think about the page attention and the VLM.
Yep.
So it's very interesting to see how one of these events is kind of triggers so many things.
What excited me most about...
thank you for releasing the open source model, right?
Yeah.
It's like...
Well, I was always...
Llama. So it's many,
Well, the biggest thing I was always worried about with when Gen AI started to really take off. You've been in AI longer than me, but I've been in the space, over 10, 11, I guess almost 12 years now. And I've seen kind of peaks and valleys. And I think I love working with academia because it's you bring such brilliant people together, such crafty, scrappy, brilliant students.
Have to be, right?
Right, and you have to be. And Gen AI is kind of like really made that, right? If you think about scale and you think, the whole Aparna's keynote around 1 million GPUs, and most academic labs don't have access to anything near that. Even 1,000 GPUs is a lot for an academic lab. But just thinking about all of the projects that have come out of your lab, coming out of Stanford, there's some really cool stuff. Obviously, like flash attention is seminal to the space. Yeah. VLM, and the thing that I really love about VLM is how organic the project is. And the reason I came, when I returned to Meta, I guess a little over 2 years now, because they called me and said, hey, do you want to lead open source Llama? And I'm like, this sounds fun, really fun. That's so cool, right? It was right up my alley. And the first thing I heard from all of our partners was, when are you going to support VLM? And I was like, what is VLM? What the hell is it? And I met Simon and I met Wusuk, and I was like, wow, these guys are really great. And I attended, we stopped by Berkeley, if you remember, and we hung out with the students. And I was like, this is an amazing project. And look at all the contributors to it. This feels very much like the early days of PyTorch, where it was there was like one BDFL, like that, but you need the BDFL, in my opinion, right? You need those people like Simon and Wusuk who have technical vision. But you need them basically to set the agenda, but then bring others along. And I think they've done a fantastic job. I've never seen. These are PhD students doing amazing work. Yeah, leading the industry.
Yeah. All these projects are the results of actually a group of students.
Yep.
Coming together and being very excited about the project. Right. When I started, I was also more, so to speak, ambitious. Trying more the top down, I believe it's a great idea.
Yeah,
we should do it. Right?
Yeah,
and obviously there are good results, but not, hugely successful. I try also with, at some point, hiring software engineers because the narrative back then was all, it was, when was this? It was maybe 2007, 2000.
Yep.
I was junior faculty then, and it was as part of the lab. It's not only me, but the lab. It's basically the narrative was what the software. The students are going to build prototypes, and then the software engineering are going to productize.
Right.
And that didn't roll.
I was going to say.
Right? So at the end, we started the Mesos, a precursor of Kubernetes.
Yeah.
Spark, and then I realized. When we started that, and it was actually thanks to Hadoop because we've seen that firsthand how they are doing this. It was that which is obvious in retrospect, it was what really I understood is that my epiphany that it's not only the software, it's about building a community.
Yeah,
that's what it is about.
Yeah,
so meetups and all of this. So you have to have people who are excited about building the community.
Yep.
And we are at the point in which I think there are two things. I think two. One is that we are might be a few months in, and it's a lot of interest, a lot of things coming on, and everything slow down to a crawl because PR reviews, people have to do something else.
Sure.
So that was the thing is that we decided to well, we need to make an effort, even more than the previous project, to open it up. So why don't you organize this kind of weekly meetings, getting the people from the community, trying to put together some kind of the roadmap, and use them almost like weekly meeting stand-ups, right?
Yeah.
To see to push the community more kind of common goal. Of course, it's not like in a company you have deliverables and so forth. Some people say, I'm doing that. But still it's much better than nothing. So that's kind of was one important thing. I think the other important thing, which was very hard. Again, you get at some point where how is this code, which is very fast growing, a lot of technical debt. And look, like not all students they are not doing the same kind of experience, which, you have a very experienced software engineer, right?
Yep.
Of course, they offset that by enthusiasm. And then we decided, if you remember, kind of half a year ago or something like that, to stop and re-architect, right? And that was the reason, because it was so hard to integrate new functionality. So again, the community and of course the contribution was kind of, slowing down to a crawl. And that was very, very, it was hard. It was a hard one, right? Because you have this kind of things going very fast. You have a lot of features coming in while you are trying to architect. So I think that, but it's again, the reason I'm mentioning these two episodes, I think that they are critical to the development of the VLLM so far. And the reason they are critical is because they enable the community to get,
I mean, these are not easy.
More contribution and so forth.
These are not easy things to manage. I mean, I think like doing a major refactor of a project like that, having, you went from V0 to V1 and all the breaking changes. I think you get some natural tailwinds from new models coming out because of the velocity in the space. So you can say like V1 only supports the new models.
You don't just support it.
I think it's I've seen this, and this is just a really, really hard thing to do.
It's very hard. Very hard.
How do you move a community, especially when people are taking a dependency on it?
No, I think it's I think you the way you do it is like the reason you do it. Of course, you are not the only one to see the. So I think you have to, and you are going to have a group of people in the community which are going to think alike. You need to create this community in the community, sub-community. Because now you are going to have, it's not like you do the refactoring and guys on the side. You have to engage as many people as possible, at least supporting you. Then explain why is that. Because people say, oh man, it's like, because if they see the pain, it's so hard to add, it's so hard to optimize and so forth. And then you present, this is what you try to do and so forth. That's kind of they give you a little bit of time, right? Even either help you or they give you a little bit of time, but it's still very hard.
I think that happens. I mean, you definitely have, when you have a project that has critical mass, I mean, I think, VLLM, PyTorch, Ray, like you have critical mass, you're in the industry, your footprint in the space. I think you're given a little more leeway than maybe like a new project.
It's exactly.
You have to establish yourself.
You have it, but it's still, you need to, its pressure is high. You need to, and I think this was like, for instance, the fact that we have this kind of meetings. It was a little bit, kind of level of trust.
And you
share, the thinking, and if people know, they are much more likely to support you, even if it's some pain in the short term. Then if they feel they don't know, they are not. It's also because you present and you open it for feedback. They feel a little bit also part of the process. But it's still hard.
I mean,
it's
crazy.
It's very hard.
The team is available on Slack. Simon will respond to my Slack messages almost instantaneously. There's an open roadmap doc that's on Google Docs. You can go and you can comment on it. There's weekly meetings with contributors. We ourselves with Meta have a weekly hour meeting, or So I think like
that's exactly what it is. So it's again, as I'm saying. It's a community.
It's a community.
So that's why, like for instance, the students are going to do the prototype and the software engineering, they are going to do that. That's not the main problem. the main problem is about how you build a strong community.
Yeah.
You know that better than anyone, right? You did a fantastic job with the PyTorch. It's kind of amazing.
Thank you.
Right, and I think that what really it's so impressive about PyTorch already. I was, like it's going to be in textbooks. It's because because of TensorFlow was so powerful, right? I mean, Spark was a little bit similar situation with Hadoop, but Hadoop community a little bit more fractured. It's not, but TensorFlow had behind Google, which is probably at that time was the best engineering organization on the planet.
Definitely,
right? So, and for something, definitely they felt everyone felt strategic, and winning in that aspect. You should say more about that, because that's kind of is like that's kind of the things I'm so impressed.
I want to be careful, obviously. Like I mean, when Hugging Face announced a couple weeks back that they're deprecating, TensorFlow and JAX, like I was really careful on what I said, because I know a lot of those engineers and PMs over there and the team over there, and
they're wonderful people. I know so many people,
right? And they're fantastic, and what they built was amazing. I think
that's what it is. It was very good. It was like good. People were going. I remember people were going and say, how to learn about deep neural network. They were going to TensorFlow and doing the examples, the documentation. That's how they were learning.
Absolutely. They have 200K stars, I think, at this point.
So
it's crazy.
Phenomenal.
Yeah. I think for me though that because I started attending some of their like SIG groups, the meetings, because we actually collaborated with Google on TensorBoard, for example. Mm-hmm. And I remember this because we were, I was like leading PyTorch, with Sumit, and we were trying to figure out like how do we build a visualization, something for developers, and TensorBoard was like used everywhere. And I remember I went over to Sunnyvale and hung out with Nick Felt and some of the engineers over there, and they're like, yeah, we'll work with you guys. And there was this but we started using PyTorch with TensorBoard, but we actually had to take a TensorFlow dependency, which is a little awkward, right? You're like, hey, you're on PyTorch, take this massive TF dependency, right? And then you can use TensorBoard. And I remember that when that PR landed to remove that dependency, I actually drove over to Google with a bunch of bottles of scotch, and you can actually ask the TensorBoard team, and I like literally handed out nice bottles of scotch.
I still have to learn from you that.
I mean, that's how you build a community, right? It was good scotch. So I went to Costco and I bought a case of scotch, and it was so much fun. But I think like it's, when I sat in those SIG, those special interest group meetings, I very much felt like, there was Google and there was like the maintainers, and then there was like all of us kind of just like listening in, right? It didn't feel like a community, to use your word. It felt like we were kind of there to sort of get the pass downs of what their plan is, but I really didn't feel like I had much agency. And that was, I think, the biggest difference between like how we approached PyTorch. And I think partly also is we kept the team really, really small. Like we actually had our Shrep, our CTO at the time, was one of our biggest supporters. And I'd walk over and have coffee with him, or Smith and I would do a review, kind of very informal with him, kind of every other month or so, and just like, what's the kind of temperature of the project? And he would always ask us, like, do you need more resources? Do you want more headcount? Do you want more engineers? We're like, nope, we're good. We'll hire a little more as we go. What a great
answer to what kind of
right?
A manager. I get a great answer.
It was great. No more
just let me alone.
Just leave me alone. Just keep giving us air cover. Like let us build. Let us, because I mean those decisions around like resourcing. Like when we were building TorchScript, for example, we were working with Uber, and Uber was there was a guy named Sydney over there who was building all the on-car autonomy, and he was basically deploying PyTorch on vehicles using TorchScript, and that was like their way to kind of deploy models in the early days for non-Python environments. And we were like scared. We were like shit scared of like cars running into each other or doing all that, because there was because all the perception was built on PyTorch. And we're like, oh my god, what is going on here? Like, and so it worked. It was great. But like we actually had to prioritize working with Uber and helping them even before we were deploying this stuff at Facebook or Meta, Facebook at the time, now Meta. And which we required a lot of air cover because it's like, hey, you can either put your engineering on like the ads team, or you can like, or build autonomy or autonomous vehicles with Uber. And we're like, well, we're going to prove this out with Uber. So it really took a lot of effort to make sure the project was sheltered in a way, that allowed us to really grow the community, which is fun. I want to ask you a different question though, because like, one of my good friends is Chris Ray at Stanford. Who I get a chance to luckily hang out with him. He's amazing. And I see the two of you as very similar in a lot of regards. You're both incredibly talented, incredibly you're thought leaders in the system space, and work at highly prestigious universities, obviously. But your students, the way you operate is almost like an accelerator or incubator of kind of innovation and startups. And like, if you just look at the LM-Sys work or the things that are coming out of the VLM project or, out of Skylab, SkyPilot, for example, like I can see like so much happening. Chris has Factory. If you go hang out with him off of El Camino there, he's got his little factory, and his students will come to me and they'll say like, I don't actually know that I'm getting a PhD, or is this what I'm supposed to be doing to get a PhD? I feel like I'm actually just like kind of building cool things, and then Chris will help me kind of like create companies out of it. And I almost see like what you're doing out of Skylab is a similar thing.
Yeah. It's, so a few things here. So one, is that, it's like, actually, it's, if someone comes, when I get new students, if someone comes and say, well, I ask them, what do you want to do after you graduate?
Yeah.
And if I don't hear them that, after I graduate, I have to think maybe I'm going to do at least to say there are three answers, right? It's I want to do academia. I'm not really sure, maybe academia or industry, or the last one is I want to do industry.
Yep.
In the last case, I tell them, you have to think twice. Probably it's not good for you to do a PhD. Because it's a 5-6 years opportunity loss.
Yep.
Right? It's not obvious that if you want to do, just that you are decided to do that, you don't need a PhD actually.
Yeah.
So I've been trying a lot to get my students to be faculty, because I believe that's extremely important to produce a future generation, right? It's like, it's not, if everyone goes to industry, who is going to produce these other people, the new generation? And for the longest time, until for 3 or 4 years ago, I was very split, right? Like 40% or so was going to academia, and then the other one was split between starting their own companies or going to industry, right?
Yep.
So it's more than 40, 50% going to academia. This has changed recently. And one of the reasons did change is not necessarily that more people do the necessary startups. It's also because the huge compensations in the space, right?
Yeah.
When I graduated, you get a industry position and so forth versus academia. Well, a factor of 2x in terms of compensation. Now it's 10x.
Yeah, it's big.
10x big. Yep. I think that has changed. But I just want to say that I always try to tell my students, you should go to academia by default. Now, this will not necessarily work for people who come from abroad, right? Because they come from abroad, they have no choice.
Yep.
Right? I cannot tell them because it's so that's different. But and then it's like it's again. I'm for me it's like I mentioned in a partners outside chat. It's about trying to figure out what are the problems and whether there are hopefully there are people who are excited to work on the problems, and then it's about try to help creating the teams. Right? All of this, in all these cases, you see that Spark, Ray, VLLM, SkyPilot, and so forth. It's a group of students, anywhere from 4 to 7, 8 work together very well.
Yep.
Right. And because you need a kind of critical mass, and you find out that if you have a group of students that work well, the progress also can accelerate, like, with a small group of people, not large, but because they exchange the ideas, they kind of, they fit each other.
Yep.
So that's kind of the thing, like the way I'm doing it. Like, it's like, okay, first, I try to tell people to go to academia.
Yeah.
The second, I am, try to work and convince people what problems I think are important, which are not always successful.
Yeah.
I'll tell you about that. And the other thing is that, there are students trying to, students help create teams and really providing all the environments for them to succeed. And again, there are many problems. I'm not, still I have a lot of problems. I try to convince people maybe they are bad ideas to work on. But one of them was not, like for instance, distributed training.
Yeah. I've
been trying for a long time.
Yeah.
And for like 2 years, no one listened to me. Like I say, it's fitting on a GPU. But and I was saying, it's fitting on a GPU. But look at the trend, right? But there are, this is one of the failures. I couldn't convince people for the longest time about that. So, and then,
that's one of those things that ebbs and flows, though, distributed training.
Yeah.
Like now, I have startup founders coming to me and saying, like, what are the best distributed systems people, and help me hire them.
Yeah.
Because right now everything is scale.
Yeah, totally. So, but it's like.
Yeah, no, I mean, when we were building TorchTune, Sumit and I came together and building a fine tuning library. Now, I guess a year and a half or 2 years ago, we kind of aimed at the GPU poor because we thought there would be a market there for the small, 8 GPU or less fine tuning. The market has quickly evolved.
Yeah. And,
I have a panel this afternoon with some of the startups, like Thinking Machines and Cursor and Perplexity, and Cursor guy couldn't make it. They're all like kind of aiming at like, several thousand GPUs to do post training with RL.
Yeah. Actually, yeah.
So scale matters.
That's why you build Ray, right?
That's right.
That's the main idea. The main idea behind it.
Yeah.
Right? Because we tried to scale up actually training at that time.
Yeah. I remember actually Robert pitching me on the early days of Anyscale with the Infinite notebook, right?
Yeah.
And actually, if you look at what Aparna talked about in her keynote, actually that is very much relevant today.
Yeah.
Because we, even internally, like we aim at obviously our problems. I think the value of academia, the big thing in my mind is like, you can actually just look really industry wide and like community wide and look at these problems and actually surface them. We are, in these big companies, we're trying to like solve our own problems and figure out how the heck do we get, the next wave of users on our platforms.
Yeah, but clearly you have the real problems to solve.
We have real problems for sure. We have a lot of challenges. We try and build tools to address them. And I think like once in a while, we're able to basically adopt and collaborate and bring external tools. VLM is actually a kind of an interesting one because we've adopted it at Meta.
Yeah.
We don't do anything that isn't NIH, right? NIH is a big problem in big companies.
We are actually so excited and thank you for that.
Yeah,
like we are super excited because it's like, I mean, Meta has a lot of super smart engineers. They do a lot of things themselves,
but they tend to be myopic. I think that they build for a certain problem and they don't see. I think that one of the really fun things about what I do is I actually open a lot of eyes internally to these engineers to show what's happening externally. And they're like, oh my God, this is fantastic. I mean, because at first with VLM, there's like a lot of skepticism. We have our own internal stack. Why would we adopt, something externally, SGLang or VLM or some of these projects? Once they evaluated it, though, it was actually pretty amazing. The lights, right? And they're like, because somebody implemented a model in like a week versus they've been hacking on something for like months trying to get something going. And the light bulbs just went off and they're like, this is phenomenal. And it's just the developer, the goal of developer efficiency. I mean, I feel like the team achieved that. And that's what we've been trying to do with PyTorch, I think other projects.
So, it's definitely, look, I obviously I'm, I know the industry. I know the other side as well, Databricks and so forth.
Yep.
And, yeah, people, like the smart engineers are always like that. It's like, I heard so many times, it's like also, it's like, I say, like, this is a great system, take a look at it.
Yeah.
And so forth. And one of the answer is that, it's good, but it doesn't really solve our problem. It's these things it doesn't solve.
Yep.
And my reaction, my answer always is that, hey, it may not solve it now, but what you have in mind is a system you are going to build, and we have to maintain it internally. But by the time you build that, you have to assume, and you have the feature, you have to assume that kind of other open source system is going to evolve, right? So what you compare in your head something which will be 1 year from now with something which is external, which is now, right? So you have to assume that you need to kind of see what, to make some assumption about all the other system is going to do in 6 and 1 years. And if there's a good community, you can impact it, right? To help. So, yeah.
It's funny, Robert Nishihara and I have been back and forth on LinkedIn on public comments, trying to figure out a good acronym for the stack, for the LAMP, for the new LAMP stack.
Yeah.
Because we have PyTorch, Kubernetes, VLM, and Ray, and which I've kind of seen that pattern a lot, right? Companies are kind of building on that stack. We obviously have our own Kubernetes style, container orchestration internally, but a lot of companies build on Kubernetes and ASEC. Like, do you feel like that is kind of like the LAMP stack of this generation? Or is there going to be like layers above that we build eventually that just kind of grow to the agentic layers?
I think that's a good stack. Of course, I'm biased. I think that Ray is being integrated very well now with Kubernetes.
Yeah.
And it's also, together they present, a pretty good infra for building this kind of system, distributed systems. Obviously, PyTorch is a given.
Yep.
VLM is very popular these days.
Yep.
So I think it makes sense for these components. Maybe, probably there will be others. You mentioned Monarch and so forth.
Yeah.
I'm sure. I think above, yes, definitely. You have to have all these kind of agents and so forth.
Yeah.
Because at the end of the day, what you want a stack is to build. You want all the components, more or less the components, to build an application on it. The LAMP stack was very successful because it has everything together, everything you need to build this kind of web services.
Yeah.
Right? That's it. And that was the killer application at that time. Right? The killer. So this, I think in this case, you're having, if the killer application with these agentic systems, then probably you need something beyond that.
There's definitely a few components that, I was just like looking at someone's awesome list, which is like code for someone basically, curated a bunch of projects and linked them on GitHub, right? And of course, for those open source people. And I think they had something like 93 agentic frameworks like linked, right? A lot of vertical centric ones, like a lot of specialized ones, but it's just an explosion at that layer of the stack right now.
Yeah.
Do you think it's going to settle down? Are we going to find?
I think that it's
it's so early.
Again, it's still early.
Yeah.
Right. It's still early because what people, what we learn, it's, it needs some time to pass in order to distill the lessons, right? Because it's a challenge building abstractions, or any frameworks, anything you do. It's about what abstraction, what API is providing.
Yep.
And doing that too early, maybe you are lucky and you are absolutely nailed it.
Yep.
But more often than not, it's so difficult, and you are going to build some abstractions, and if they are not good, and because maybe at the time you build, they're great, but the field is evolving so fast that they are not going to be any good anymore, right?
Yep.
I see the same in like post-training frameworks. So I think that you need to make, in some sense, you need to make the minimal assumptions and to be prepared for change. We are building this post-training framework right now, SkyRL, and we're looking at that. And what I told people, look, it's like you have to be prepared to, not only to iterate, but to rewrite.
Yeah.
Right? Just rewrite.
Yeah.
Because
totally.
things will change. If you are not prepared for that, it's like because I cannot guess what the future brings.
No,
so that's kind of the things. Even for instance, the lesson with Ray. So Ray is like we build as a Ray core, and then we build a lot of libraries and so forth.
Kind of built out from there. I remember that. Yeah.
But the most probably he's still most popular. It's the Ray core, and the reason probably is more popular because it's so simple, right? Yeah. It's like 5-6 functions. Of course, you need to do a lot of things on top of that if you want to do it. That's why you have the libraries. But that kind of was a more stable, right? Basically, that IBA hasn't changed in years. So I think, that's, and well, we have some libraries like RLib. It was a very complex library. RLib was rewritten multiple times.
Yeah.
Right? Wow. Because always you need to refactor it, right? Because always you have a new kind of algorithms, RL algorithms. Yeah. Right? And then, it's you to fit it in the current abstraction didn't really work. So you have to, you add it, but then tape it and so forth, but then you need to, take it away and rebuild it. I think it's like 3-4 times. So, and probably even now it's not perfect. So it's far from perfect. So that's kind of what I'm saying. When I see these ones, because I talk with people and say, some of them say, oh, this is great, but when I try to do this, it doesn't really work. I'm going to Python. Okay. Yeah. It's like, and then say, but and some libraries say, but I'm doing asynchronous calls. Well, but you have async IO in Python, so what? It's like, so yes. So I think, and to people, what I'm telling them, look, you have to use a low level APIs. Yeah. And you build higher level APIs only when you start copy and pasting the code.
That's right. Exactly. You're absolutely right. I mean, it's exactly how I think over the years we start with very much a library approach, and how do we build this like invariant as much as possible invariant to the space, and then you start to build a higher level abstractions. If you go straight to the high level, it's doomed for failure right from the beginning, right?
Because you cannot guess.
You can't guess. And somebody's always going to want to click down into a lower level abstraction. I've seen it over and over and over again.
Yeah, and you get it, and what it kills you, and I see that obviously, we've seen that in Spark, also we see that in Ray and so forth. But it kills you because you have these layers and so forth. And when you still spend the most of time not writing code, but debugging, testing it. Yeah. Now, when you're debugging, when you have errors, now you are going to have these errors. It's going to have different layers. It's people working at these layers, they have no idea what are these layers are. Like Spark was saying, I'm doing Spark, and I see this kind of error in Java. Why? I'm doing. We have PySpark. Python.
That's right. Yeah,
I'm doing writing Python kind of. And this is Java. What the hell is that? Same. It's like with something like I'm doing these things at the library. Like I see this kind of. What does it mean?
I think for me, like the fun part,
it's a disconnect.
Yeah. So the fun part for me is is working with the power users. And you got to be able to attract those folks.
Totally.
That will iterate with you, right?
Yes.
I mean, in the early days of PyTorch, you had Clement and Andre Karpathy and all the folks and the team. Like, I think one of the cool things about these projects that start with researchers, for researchers, by researchers, they build for what they would love themselves to use. Honestly, like the JAX team at Google is very much like that. They're a bunch of great AI researchers. I know they're amazing, and they build something that they just love. And I think that's what's kind of misunderstood about that team. But if you can iterate really quickly and find the right abstraction and give the people the right flexibility, I think that's it's really interesting. So.
Yep.
I feel like we should. I think maybe let's have this conversation again in a year.
Absolutely.
And see what the lab stack evolves to.
I would love to.
I'm kind of curious to see what happens. So
I would love to.
My prediction is maybe we're not there yet. But I think we'll probably get another project that's maybe like a standard. We'll see though.
Yeah, we'll see. Yeah.
Awesome.
It's like that's why exciting about the field, right? It's like you never know.
Yeah, Jan, it was super fun to hang out. Thanks for coming. Thanks for doing the fireside chat with Aparna, and thanks for chatting with me today.
Thank you so much for having me. I really enjoyed it.